Hello, and welcome to Philip Brown's Computer Networking Lab. You're watching the instructional video called Multicast Sparse Mode using AutoRP. We are looking at a sample diagram of a client computer and a server connected together by three routers labeled A, B, and C. We're going to configure the multicast network on these components, and we're going to make router B the rendezvous point on its loopback interface of 1.1.1.1. These are the steps that we're going to use to configure multicast in sparse mode. 1. We're going to verify that the unicast network is working correctly. 2. We're going to configure the router for sparse mode multicasting. 3. We will configure the rendezvous point and the mapping agent. 4. We're going to have a client computer request multicast traffic. And 5. We're going to have the multicast server send out multicast traffic. The very first step in creating a multicast network is to verify that the underlying unicast connectivity is working correctly. Let's ping the client computer. The pings are successful. Let's also try to verify that we can ping the router interface that we plan to configure the rendezvous point on. This is also working correctly and shows us that the multicast server is able to talk with both the client computer and the future rendezvous point using unicast ping packet. Let's look at the commands needed to pass multicast traffic through the routers using AutoRP. In the global configuration mode, you will need to type in the IP multicast routing command that enables IP multicast on the router. The IP PIM AutoRP listener command actually is not a true listener. It is a forwarder that floods the location of the rendezvous point using the dense mode protocol. To simplify things, we're going to configure it on every router that is participating in multicast, even when it's not needed. In the interface configuration mode, we will need to type the IP PIM sparse mode command that enables PIM sparse mode on the interface. On the rendezvous point router, the IP PIM SendRP announce command creates a rendezvous point. The IP PIM SendRP discovery creates a mapping agent that communicates the IP address of the rendezvous point to all the other routers. We can choose to put the rendezvous point and mapping agent on the same router or on separate routers. Again, let's look at the diagram of our simple network. The first step is to verify that the unicast traffic is working correctly, and we have already done that. The second step is to configure multicasting on all the routers that will be forwarding multicast traffic. As we have done in previous videos, we are going to configure all the routers for multicast routing, and we're going to configure all the interfaces that will be participating in multicast with the sparse mode protocol. We also need to configure the AutoRP listener to forward the IP address of the rendezvous point to other routers. Now that we have configured the routers for sparse mode multicasting, it is time to perform the third step. Router B needs the loopback interface to be configured as a rendezvous point using the IP PIM FIN-RP announce command. We will use a scope of 3 so that this will only influence routers that are within 3 hops away. And next, the mapping agent with the IP PIM FIN-RP discovery command. Its job will be to tell everyone where the rendezvous point is. Let's configure the client computer to receive multicast traffic from 234.234.234.234 using the IGMP join group command. When the multicast server sends out a multicast ping packet to all the client computers that are participating in multicast, the client computer will respond with a reply ping packet. The client computer with the interface address of 10.0.3.2 has replied. The multicast is working between the server and the client computer. AutoRP is Cisco's proprietary solution for allowing routers to learn the location of the rendezvous point. In the next video, we will discuss the open standard solution. I hope this video has been informative, and I thank you for viewing.